How's it going, guys? I hope everyone's doing all right. I'm gonna take those off real quick. So, first of all, what we're gonna do today is I'm gonna actually paste my Twitch in the Discord because it looks like it didn't notify everyone, but we can fix that real quickly. So, let's just go up there and do this real quickly. Alright, so we're all good there now. And just gonna move this back real quickly. Okay, so what is today's stream gonna be about? Today's stream is gonna be about inventory management. I'm really looking forward to this because I've made quite some progress in terms of all the other stuff. I'm pretty happy with the way optimizations are going right now and everything. So we're getting to a pretty good point in the game. Hopefully I can release that first episode towards the end of November is what I'm thinking. So, and next week's going to be a big week, streaming like every day, and we're going to get a lot of work done, hopefully. Yeah. Flare YouTube, how is it going? I'm doing all right. How are you doing, my friend? And Langors, how's it going? Hope you're doing all right. And Voxel Riffs, yeah, the bot did mess up, but we got it all figured out, so it's all good. And I am doing all right, Flare YouTube. Thanks for asking. But yeah. So today is going to be a pretty big stream. There's a few things that I'd like to mention though, first of all, about some of the changes I've made. So first of all, let's just launch the game, see what's going on. So if we hit play game, we get all of our worlds listed up here. And we're going to change the way this looks because it's kind of ugly right now. And I want it to be more like Minecraft where it's like picture once we get around to that, but not now. And then like the world name and then like last accessed, all that type of stuff, and sort these appropriately. But if we take a look at the actual folder for our Minecraft clone, I've sort of restructured it a little bit. So we have this folder called, or directory called worlds. And then inside this directory, and can I zoom in? I guess I can. I don't like that though, so I'm not gonna do that. Okay, and then inside of this directory, we have all of our worlds listed and we can click onto them. And now I've messed up my view. Wait a second, let me fix this real quickly. I'll fix it later. Okay, so anyways, if we click into here, you can see that we get like the world.bin, and right now all this contains, if we actually open it up, it's just a binary file, but if we open it up, all it contains is this, and then if we open this up in a hex editor, which I believe we can do with like view hex somewhere. I know I have a hex editor on Visual Studio Code, it's just if I can find it, that's the question, I guess. Let's see. Somewhere in here? No? Yeah, maybe? Google to the rescue? Actually, I think I can do Control P. Yeah, there we go. Hex. No? Okay, well, if we were to look at this in hex, all this is the world's seed, currently. So it literally just stores the world's seed. That way we can, like, reload it. And then we have all of our chunks serialized here. We are going to have to come up with a compression technique, because if we take a look at this, this is just a 12 chunk radius that's serialized in there, and it's 220 megabytes. So not bad, but like we really don't want to be having that build up, because if you move to another radius, you're already up to half a gigabyte, which isn't very good. So there are certain optimization techniques that we can do and stuff. But yeah. And SE Woods, how's it going? I hope you're doing all right. Oh, and the bot did post it. It was just late. Okay. So, anyways, though, what's happening now, I guess, inside of our Minecraft game is it's going through all those folders and then it's just listing the names so that we can see them here. And if I click on one and I hit load world, it doesn't show any feedback, so that's another thing we got to fix. We get the world loaded, and you'll see I've placed some sand here just to make sure that I could actually tell, like, this was the appropriate world. So then if I go ahead and place down a few blocks, and then we'll actually go ahead and save this in a minute too. So if I wait for that and then I hit F10, it's going to close down the game. But as it closes, it goes ahead and serializes anything that's in range. And then if we were to hit it and load it again, then you'll see that we got our changes saved. So we've got a way to basically save our changes and everything, which is really good. And we can sort of open up our worlds and we can create new worlds. So if I were to go back into there and then hit create new world, then it'll give me this, and then I'll say like my new world 3, and then I can hit create world, and it generates a new world with a new seed, they all look very similar right now because I've changed the generation techniques right now. And the only reason I changed that was because I didn't really like the way that it, it wasn't generating good. So I was like, I'm going to change this for now until we get to the point where it's actually generating correctly. But anyways, if we go ahead and do that, you'll see that it created inside of here. And you'll notice that that serialization is like blazing fast too, super fast. But it created this My New World 3. We got all the chunks in here. And then if we go ahead and were to run this again, we've got this My New World 3 in there too now. So, and another thing I don't really like about this right now is it's not sorting it by date last accessed. It's just taking them whatever order the iterator is giving it to us in C++. So we got to fix that. But yeah, it is working, and that is what's good. So today we are going to be adding some more stuff to the game though. Fire YouTube, you have to change the grass texture. It's using concrete one. Yes, that's something else I did want to change. So maybe we can do that first because that should be pretty easy to fix. Let's talk about a couple of the other changes I made though. So if I go back into this world, you'll notice that first of all, like, look at how smooth me moving my cursor around is. I mean, this might not seem very smooth to you guys. I don't know, especially with like stream latency and everything, but this is way smoother than it was before, and I'll talk about what I did to fix that. And also, Essie Woods, am I on a well-deserved vacation now? I guess I kind of am. I have like a week until my next job, which will be fun. So I plan on coding a lot with our current Minecraft game. I'm actually going to be going out of town later tonight, which is why I'm streaming today instead of tomorrow. But yeah, so that'll be fun, and it'll be nice to relax for a little bit. But technically, I've been working from home for like the past long time, so it's felt like just a very long vacation, I guess. But right now, this is like super smooth. If I move forward and backwards, you'll notice that there's like pretty smooth latency and stuff. And the main change I made, and now it's lagging kind of weird and stuff, but the main change I made to sort of get to this better state of like rendering and everything is a couple things. First of all, if we look at the world, or actually not the world, but the application. Oh, I've got that open too. Okay, so if we go into the application and we look into here, I'm still debating whether or not I want to keep this, but basically what I'm doing is we basically have a target frame rate, which is 60 frames per second. Our next target is 30 frames per second. So if we don't hit that first target, we hit that one. I might query like the hardware just to get the vertical sync. So like get whatever the refresh rate on the monitor is and target that, and then divide by 2 for my next targets. And then what I do is I get the actual FPS, and then I make the thread sleep for however time we have left until we hit that frame rate. And if we drop frames, then I go to the next frame rate that we want to target. And then I update the scene with a fixed delta time. So you'll notice I hit the delta time as the target frame rate. And if we don't hit either of these, then we just use whatever the actual FPS is. But yeah, so basically we first of all make sure that we have this fixed time step, which is good because that means that like just updates are a little bit easier to handle and everything, and it's more repeatable. Like it should play pretty repeatable. And if we go into the physics itself, there was one big change I made in here, which was we have a physics update rate, and I've set that to 30 frames per second. And the reason I did this was because you don't need to update the physics every frame if you're running at 60 FPS, and you still get like the same speed. And so basically what I do is I accumulate delta time, and then we check and see if it's greater than 0. If it is, we subtract delta time from it, and then we update as many times as we need to get our accumulated delta time down. And I just realized this should not be minus equals delta time, but it should be whatever our fixed frame rate is. Yeah, it should be this, so that's bad. But yeah, so basically it'll just update up to 2 times during a single frame, which should mean that we run the physics like 30 frames a second instead of 60 frames a second, which should give us a little bit smoother rates. And it also makes our physics completely, it makes it a little bit better because we're no longer operating on like half boundaries of frames and stuff. Instead, we're completely operating on like a fixed frame rate, which is good for the physics since it means that our floating point operations are going to be more determinable and stuff. So yeah. And Flare YouTube, you bought a new phone today, so you're so happy. Awesome. And it's going to come in November. That's quite a ways away, but that's still pretty cool. So if I did that, I'm just making sure I didn't break anything by changing that. We should be updating the frame rate at 30 frames per second. Yeah, and now this feels way slower. And the reason it feels slower, and it's like lagging. Maybe I should have left that. Maybe that was right. Okay, so let's change this back. I'm still debating whether I want to keep this or not, or whether it's even good. So, you know, this is all experimental. But yeah, we'll leave that the same for now, and then I'll look at that a little bit later. Another thing though that's really cool is I put together this Excel spreadsheet. So I've been using Excel to like manage how much memory we're using up, right? So this is for like how many vertices we're using per sub chunk, and then depending on the chunk radius, we can see how much RAM we'll be using total for chunks. So we go up to 2.7 gigabytes right now for 32 radius. But I also made this thing, and this is the jump boost. So using this, we can put gravity to a certain whatever we want to set it to. We can also put like our, where is it? This is our initial jump boost. So if we tweak these values, we can set exactly how high the player will go, which is really nice because this means that we can make completely determinable physics. If we want the player to jump at 1.6 blocks high and that's all he jumps, then we can do that. And then you can see this is kind of the path he'll take. So I've made it so that it should speed up on the way down. So you follow a parabolic path, and then as soon as you hit the peak, gravity kind of becomes heavier until you hit the ground. And this is following like, I watched this GDC video and they were talking about making your jumps better and everything. And I guess Mario does this too. And it's sort of the game feel that people have come to expect. But yeah. And your birthday's in November. Cool. Happy early birthday. So this is really useful. But basically what this means is right now we've got our jump boost at 4.7. Say we want to jump over 2 blocks high. And we can see that this is true too. So it says we should only hit 1.6 blocks. So if I go ahead and I try and load this up, we can go, I'll load that one. So if we go into here, yeah, I'm gonna have to check that physics, double check and make sure it's working right. But if I put another block here, if I jump, I cannot jump over this block no matter how hard I try. And you'll see I'm jumping about the same height, which is good. It's what we would expect and it's what we want. Like, you don't want the player jumping different heights depending on the frame rate. So this is pretty standard, like it just keeps going. But say I want to be able to jump 2 blocks for whatever reason. Let's get off that. What I can do is I can go into here and I can tweak these values. So say I go up to 5.7. That should get us 2.5 blocks, but that's a little too high. So let's go to 5.0. That's not high enough. So then if we go 5.2, almost there, 5.3. Okay, so 5.3 should just barely get us over the 2 block boundary. If we set our jump boost to be 5.3 initially, then we should be able to jump over 2 blocks. So if I go into here now and we go to the player controller setup, which is in here, and I go and set, yep, the jump force. So let's set this to 5.3 instead. So, and I believe that's what I set, right? Yeah, 5.3. So now that we have this, we should be able to jump over 2 blocks, and you should see. And Tribread, thank you for subscribing. That's pretty epic. So if we go back into here and we load our world up again, then you should see that if we jump now, we can just barely jump over that edge. And the calculations mimic the code in the Excel spreadsheet. So no matter what, like, I should be able to do the same thing. So now if we have 3 blocks high and then we go back into here and we change this to 6, almost there. If we change that to like 6.4, not quite. 6.5, there we go. So 6.5 should get us a 3 block jump, and then we can go into here, change that to 6.5F, and then if we go back in, we'll be able to jump 3 blocks. But yeah. And how's it going, Miri4F? Hope you're doing all right. So if we hit this up again, then we should be able to now jump 3 blocks high. And we'll jump, and we can make it over 3 blocks, just barely. There's some physics glitches that I still have to figure out, because you'll see that if I am running and jump up, I kind of hit that top block. So yeah, I gotta figure that stuff out. But yeah, this is good. So now we can basically set different types of things in our game code, and we know exactly what the effect will be in the game world just by doing some simple calculations. And the way this works too, by the way, and I think this was 4.7 originally, the way that I did this, it basically just mimics exactly what we're doing in Gravity. Oh, and another good thing, this tells us how long the jump will last too. So you'll see that this will take 37 frames. So at 30 frames per second, that means we'll get about a second long jump to jump up and then come back down to where we originally started. But the way this works is it just mimics exactly what the game code is doing. You'll see that gravity just takes whatever we set our gravity to over here, multiplies it by 0.032, which is our frame rate. And then our Y velocity, it does some fancy math to see if we've hit the peak, and then it increases gravity. That way we get that kind of heavier fall. But then it just takes the value above it and multiplies that by 0.032. And then the Y position just does gravity plus Y velocity times frame rate. And that is how that works. Or probably that's Y velocity plus gravity times frame rate. Yep. But yeah, so basic physics calculations, and then we graph that, and we can sort of visualize how this works. I was doing all this by hand, and I was like, why am I doing this by hand when Excel exists? So yeah. Do I know anything of Portuguese? I do not. I know some very, very light Spanish. So yeah, I grew up in Florida, so we had to take Spanish for quite a while, but I never learned it very well. Okay, so what are we going to be doing today? We're going to be doing inventory management, which should be easy. So the first thing I'm going to do is I'm actually going to open up a sprite because I don't have any inventory slots kind of drawn out. So we need like a drawing to be able to use that. So I'm going to go into here. This is where I just have all of our sprites, and then we'll just go and take up one slot, and I guess I'll do this just like a white color, which is how Minecraft does it, I think. And we'll just draw a square. I'm not an artist, so this is not going to be the best that it could be, but we're just going to be doing exactly like Minecraft, which means it should be simple. Okay, so we'll do that for a regular inventory slot, maybe just like another like inside line, right? That's a little bit darker to make it look like it's kind of beveled. And then I'll erase that stuff. Okay, so that's our beveled inventory slot, and I think that's gonna be the highlighted colors. So we'll have that one, and then let's just copy that so that we can have like a non-highlighted colors, which indicates which one is in use and which one's not. So then the non-highlighted colors we'll just do darker. So we'll do that. And I cannot seem to draw straight. Okay. There we go. And then I don't know if that should be darker too. I can probably just use the box tool over here. Let's see. Yeah, we'll use the rectangle tool, and then I'll go a little bit darker. Nah, I think I like it better light. Okay, anyways though, so that's going to be our inventory slots. They don't need to look very pretty, but yep. And Tribread, how's it going? What program am I using to make the sprites? This is a sprite, so you can see it up here. I believe it's actually free. So there are 2 ways you can get this, and I didn't know this before I bought it, but if you're good with like compiling and stuff, you don't actually have to buy it. Because I think you can compile it yourself and like just do it that way. I'm 90% sure, because I remember seeing something and I was like, oh wow, you don't even have to actually buy this. But yeah, it's pretty cheap. I think it's like 10 bucks. So it's good to support the developers, and it's a pretty nice program. Yeah. Miri4F. Oh yeah, no problem. Do you plan on adding support for custom models for different blocks? I do want to take a look at that. It's going to be a little bit harder to figure that type of stuff out, but we'll take a look for sure. And Flare YouTube, sorry, I just saw that. English, just my secondary language. You're from Brazil, so primary language is Portuguese. Okay, nice. And Langors. Okay, now you guys are speaking Portuguese. Okay, I cannot follow. Okay, so we've got these in here. What I want to do now is just get the pixel coordinates so that we can add these to our sprite sheet. So this is at, if you look at the bottom right corner here, it tells you like what the pixels are and stuff. So we can see that this is at 0, 144 and it's 16 by 16. So I'm just going to go ahead and actually I think I have it open. We'll go into the HUD sprite sheets and this will be our selected inventory slot. And we're going to say this is UV start X 0 Y. I can't remember what I said there. Let's take a look at that again. Whoops, wrong thing. Okay, this is 0, 144. So that's 144. And then we can say UV size is 16, 16. And that should pick it up automatically for us. And then I'll copy that, paste it. And this is going to be our regular inventory slot. I guess I'll call it regular, just to show that there's a difference. And this is the same size and it starts at, let's see what this is. That is 0, 160. Okay, so we do that 0, 160 and we're good. So now we should have access to these in our sprite sheet inside of our code, which is nice. Use configuration files if you ever have a chance, or even better yet, create a whole editor, which is super cool, but I don't have time for that. Have I ever tried paint.net SEOids? I have not. Is it built into Windows? No, maybe not. Yeah, I don't know. I've used Paint, like regular Paint, and then I use Inkscape for like vector graphics. I try and go free where I can, and I actually really like Inkscape too, but yeah. And I've tried Photoshop once or twice, but I really just don't like it. So I use Krita if I ever have to do like drawing type stuff. Okay, so we've got those in there now though. What do we want to do next? We want to go and sort of create our HUD. So I've got this file main HUD, and this is where I plan on putting all the HUD elements for our game. So if we go to main HUD.cpp, we can sort of go into here. You can see I've got the block cursor sprite, which is just the cursor in the middle of the screen that you get in Minecraft. So we're going to add in one more here. We're going to say static const sprite star. This is going to be our regular inventory slot, and we'll initialize that to null pointer. And then we'll have static const sprite star selected inventory slot, which equals null pointer. And we've got this block cursor size. We should probably have a static const glm vec2 inventory slot size equals vec2. I'll probably do like the same size for now, and then we can update these as needed. Okay, so we're going to center these on the bottom portion of the screen. And then we also need an index. So we'll have a static int current inventory slot, and we'll initialize that to 0. So we start on the left side, and then as we go through, we'll just sort of go through those inventory slots. So what we'll do is we'll say if regular inventory slot and selected. Just make sure that we have those and they're not null pointers. And then when we unload stuff, we'll of course reset these to be null pointers. That way we just do all of our housekeeping stuff. And then inventory, what was the other one? Selected. Okay, so that's all good. So if we have both of those, then what we're going to do is we'll also say static int number hotbar inventory slots. I think we have 8, right? Or is there 9? I think there's 9 because it follows the keyboard. So we'll do that. And then we'll say for int I equals 0 until I is less than number hotbar inventory slots I++. And we'll just draw each of these. We want to figure out where we're going to start this. So we'll say glm vec2 current slot position equals glm vec2. We want it to be at the bottom of the screen. Screen ranges from negative 1.5 on the bottom to 1.5 on the top. Negative 3 on the left to 3 on the right. So if we want to center these, we can say float centered or start x position equals, we have the number of hotbar inventory slots times their size dot x. So that's how much we've got. We can divide that by 2. And then we can just do a negative since we are centered on 0, 0. So then we'll do the start X position. And for the Y position, we'll do like -1.4. We'll do 3. And then we can change that if we need to. And we can add it up here if we need to as well. Okay, so we got the current slot position. And then what we'll do is we'll just say for now, render, draw texture, make sure that we actually have these all set up properly. We'll do the regular inventory slot. Position is going to be current slot position. Not that. Size is going to be slot size. Yep. And then color is going to be just styles default style, because we're not going to do anything fancy to that. Okay, so regular inventory slot, we just need to make sure we dereference that since that expects a const reference. So this should draw our inventory slots. We just need to make sure we load them as well. So we can go ahead and say that equals the address of menu sprites dot at std string. This is regular inventory slot. And then we'll copy that, selected, selected, selected. And I believe that's what we called them. Regular and selected. Cool. So with this in place, we should get inventory slots showing up at the bottom of our screen. Let's see if that works. Crescent, how's it going? And let's see, Essie Woods. Oh, okay, you guys are talking about paint.net. Have I seen the new trailer for GTA? I have not. All right, so let's see if that all worked. So if we load up our world, do we get inventory slots on the bottom? We do not. Okay, so, and also you can see that the block cursor is the thing in the middle of the screen. This thing right here. So if that's drawing, we know we're hitting that update loop, but it looks like we're not hitting those. So let's go ahead and log a warning if we're not getting them. We'll just say logger warning could not, or inventory slot textures not loaded properly. So let's see if that's the reason we're not seeing them. If not, it's probably we just have the positions off or something like that, which I have been known to do quite often. Okay, so we're not getting any warnings. So that means it's definitely loading it and it's running through this path. Let's actually, oh, I'm not actually incrementing the position or anything too. But I think this is probably the reason why. Let me just double check the camera projection size. Yeah, so let's go into this camera. Okay, it looks like it's not defined here. Camera.cpp. Okay. Yeah, so projection size is 6:3, so that means -1.5 should be the bottom. So that means if we started at -1.3, and actually this is the bottom left corner, so if we started at -1.4, we should be fine too. Let's put these at 0, 0 though for now, and I forgot to increment the slot position, so we also need to do this, .x plus equals inventory slot size .x. So let's try this again, see if we get anything on the screen this time. Okay, so we hit all that. Still not getting anything. Let's hit a breakpoint, make sure that all these numbers make sense. Okay, so we get the start position is -0.45, which should be fine. 0. Okay. What is the start X position? Is -0.45. Yeah, that makes sense. And I put it at 0 just to see if it would show up in the center of the screen. So this should be like the center of the screen, but we're still not seeing anything. What is this texture? Is this texture valid? Come on, I want to hover over this. Okay, so we've got a texture here, 2D texture, width 512. Yep, that's all right. UV start is, yep, that looks right. What about the UV size? Okay, that all looks fine. So, current slot position is that thing that we just checked out. That should be fine. What's the size? We just checked that, didn't we? Yeah, 0.1. 0.1.1. Okay, so that all looks good. Let's go into here and see what's happening. So we set all those. Am I in debug? Okay, good. Okay, so we say draw texture triangle. Okay, so this gets a batch. And then we get texture slot. What is our texture slot? That looks fine. Okay. Let's change our shaders up real quick and see if we're rendering stuff, and it might just be that we put in the wrong texture coordinates or something. So let's go back into here and we'll change our shader to just output like this. Wait, no, that's fine. Okay, I thought that was bad. I was like, that doesn't look right. Okay, so we'll do frag color equals vec4. Yeah, we'll do 0.1, 0.8, 0.7, 1.0. Okay, let's see if we get squares where they should be, and if we do, then that means that they are rendering, we're just not getting the correct texture coordinates or something. It seems my chat's changed language on me, so I don't know what you guys are talking about now. Okay, yeah, so we are rendering them. You see these squares that are showing up. So that tells me that it must be our texture coordinates are just bad. Or something. Or, oh, you know what it is? I never exported that drawing. So everything's probably working fine. You just need to make sure to export your drawings to a PNG file, which I did not do. So let's overwrite that file. And you know, now if we run this and we put this back to start X position, or no, this was, we said minus 1.4F. I think 3, but 4 is better. English, yes. Okay, so now if we run this, we should get inventory slots on the bottom because I actually exported. There we go. Look at that. So we've got those. They are very small, so I'm going to increase the size of them. And also, does Minecraft, they usually have like a semi-transparent background there too, don't they? So let's go ahead and add that. We'll do it like black, and then we'll just do like semi-transparent. So we'll bring down that opacity to like kind of half, and then I'll just color that in. And I have to make sure not to color over my other pixels on accident. Okay, I'm just gonna do a filled square because that's probably safer. So if we do that, I'm gonna undo that, and then we just do this. There we go. Okay, and let's get out of that. Okay, did I do that right? No, I didn't. Okay, that should be there. There we go. Okay, so let's export that one more time as well. No, not the sprite sheet. Whoops. Export. Okay. Yep, that's good. Cool. And let's increase the size of these because that was way too small. We'll do like 0.2. See how that looks? So double the size. And we'll see if this looks semi-right. Okay, so if we hit load world. There we go, look at that. It still looks really ugly though. I think my colors are just very off. I'm wondering now like what Minecraft uses, because that just looks so off. I'm gonna Google what Minecraft uses now because I have to see. Minecraft. Let's just look at a screenshot. None of these screenshots are gonna show that. Okay, there we go. Thank you. Okay, so they just do like gray and then like a dark opacity. Oh, and then they do like an outline around it too. Okay, so let's steal that because this looks horrible and I want it to look somewhat good. I'm gonna make these a little bit bigger first of all. So let's go ahead and we're gonna delete all this stuff. Okay, and then we're gonna go ahead and just draw within this square. Let's do filled rectangle. We'll do that opacity. Yep, so we still got that color. So we'll do this. And then we'll do a non-filled rectangle. Do I still have that picture up? I do. Okay, let's do like a gray and then we'll do like a black background border around it. So we'll do like oh man, you can't even see that too. Let's change that. This should be 1 pixel too. Okay, so 1 pixel. I cannot see what I'm doing because this just isn't light enough. So we'll do that, and then I might change the color. And this is still half opaque, so we'll make that. Maybe that's why I couldn't see it. Okay, so we'll do this. And then we'll do a black border. So 1 there. Is that too dark? That's too dark. Okay, 1 there, and then like 1 there. No, I really don't like that. So we'll just do the black border for now. And we'll see how this looks. Let's try this maybe. No, that doesn't work. We'll try this. We'll see how this looks. Let's copy that, and then I'll change it slightly for the bottom one. So copy that, paste it, put it right there. And then for the selected, we'll just do like a white color. Grab that again. Like that. Okay. Or actually, no, I think the white color should be on the inside. There we go. No, we'll do it on the inside and outside. And then we'll do like a smaller border on the inside. Okay, let me grab that color. And we'll do that. Okay, so we'll see how that looks. Hopefully it looks a little bit better because I want it to look somewhat good. Yep. Marticus, how's it going? We are making a Minecraft clone. So right now I'm trying to make inventory slots that don't look horrible. Because currently they look pretty bad. Now that I'm looking at this too, let's actually go ahead and just grab that color real quickly. We'll do this, and then I'm gonna do a double border there too. Okay, and then hopefully this looks a little bit better. Okay, now we have to adjust our coordinates. So this one should stay the same, but now they're 32 by 32. So let's just change that up. And then, or actually, I guess this one's the... I think I have these backwards. Regular is the bottom one. Okay, no, that's right. Okay. So let me just see what the coordinates are for that. That is at 0, 176. So let me just change that. And let's see how that looks. Hopefully it looks a little bit better. And Player YouTube, Gabe, Sony announced God of War for PC. That's pretty cool. I haven't played God of War though, so I am not exactly sure what the significance of that would be. Sorry about that. Oh, do I have to export that? I think I have to export that as well. Yeah, so let's make sure to export this. Export, replace that. Okay, let's see how this looks. It still looks like crap. But, you know, it works. So I'm probably just going to leave that for now. Wait, maybe I do have the regular in the... Yeah, I think that's the highlighted one. I think I'm showing the highlighted one. I should be showing the regular. Am I doing that right in the code? Yep, so we're doing regular inventory slot. I think I just have them switched here. Yeah, regular is the top one. Okay, so I do have these flipped. So this should be 144. This should be 176. And then let's go ahead and just move this guy above him so that they're ordered as well. Okay, cool. So now if we go back into here, does this look a little bit better? No, that looks a lot worse, actually. Okay, whatever. The fact is, we just need something there so that we can actually start using it. So we'll just do that for now. And has anyone heard of a game called Book of Travels? I haven't either. But new RPG game looks really cool. Huh. Yeah, there's so many new games coming out and stuff all the time, and there's a lot that I want to play, and I just haven't had time to play as well. I started Alien, I got to like the middle of it, and then I haven't had time to play in like months. So yeah, I wish I had more time to play games and stuff, but just not now. Maybe this week, this upcoming week. Okay, let's go ahead and we'll draw this texture if we're not on the, if I does not equal the current inventory slot, which is an integer, we'll do that. Otherwise, if we're on that one that we want to highlight, then we do this, and this should be outside of the if statement. Then we'll draw the selected inventory slot. So graphics don't matter too much here. The important thing is that it works, and then I'll ask my brother if he can draw way better looking graphics than what I'm making. Okay, so I have that backwards. Don't I? Yeah, that should be not equals. Okay, so now we should have a white slot for the first one, and then we'll add in functionality so that when we scroll the mouse wheel or press a button, it changes the selected slot. So that's good. Gabe, what is my PC's GPU? I've got an RTX 2080, so it should handle like most different things. But yeah, okay, so this is working. It looks kind of all right. Yeah, I still really don't like the way these look. We'll have to change that later. Okay, but anyways, this works pretty good. So we've got the main HUD. I'm thinking about the way I want to organize this in the code. So we could go like 2 options for the controls, like how this is controlled. Clearly, all the code that controls this stuff should be inside of the Playercontroller.cpp, because the player controller controls the player, right? And HUD management is part of a player thing, right? So what I'm thinking is, what we do, we have like a extern int up here, current inventory slot, and we'll set that to 0. And then once we go into the main HUD, this becomes an extern int, actually, and we can't define it up here. So we do that, we have it defined inside of here, and we'll just move this out to here. That way this is global and our player can see it, and then we can manage it from within our player, but then all the drawing and stuff happens inside of our HUD. I'm not sure if I like this, but you know, we'll think about it, and then I may change it in the future. Okay, and I don't like putting that above the functions. We'll put it down there. So yeah, so we'll do that for now. And then inside the Playercontroller.cpp, what we can do is, this is gonna be like for a few different things. So I'll make a function. We'll call this static void update inventory float delta time. So we'll do that, and then we'll put this down here. So we can do that, and then we'll have like our hotbar keys and everything. Man, you guys are still speaking Portuguese. Okay, so we'll do this, and then we can go ahead and say if input scroll wheel. Do we have scroll? We have screen X. We don't have scroll. Okay, so we should add that in. We can add in some hotkeys though. So we can say if input key begin press 1. So we'll say GLFW key 0. Or no, we want key 1. Okay, so at that we'll set the inventory to key 1. Let's actually just do a loop here. We'll say for int I equals 0 until I is less than 9, I plus plus. And I think GLFW key 1 is that, 49, 50. Okay, cool. So they do set this up. So then we can say plus I. So if we hit any of these keys, then what we'll do is we'll say main HUD, which we have to get some includes up here. So where's this? That's inside of the GUI. Do we have any GUI stuff up here? No. Okay. So we'll say hash include GUI / main HUD. And then we'll go down here. And we'll say main HUD current inventory slot equals I minus... No, we can just say I. Okay, so that should be... So if we hit any of the keys 1 through 9, we should switch to that inventory slot. Let's see if this works. Oh, I have to update this too. So for now, inside of survival mode, we'll update inventory slot. And we'll pass delta time. We will do the same thing. Not spectator mode, because spectator mode doesn't have any of that stuff. Okay, so we'll do that. What version of Minecraft am I aiming to recreate? The earliest version. So what I'm doing here, for those of you who are a little bit newer, is I'm basically coding like the basics of a Minecraft clone, just getting some basic world generation, inventory management, block breaking, that type of stuff. Sort of the core of the game. And then I'm going to be making a YouTube series that goes over how to code it. So it'll be like a more targeted to a more general audience, so it won't be very specific on the details. but it will be specific enough so that if you follow the series, you should be able to pick it up and then go and code it yourself. And so first I have to code it myself so that I have something to reference when I am actually talking about it. So that's what we're doing in this stream, is beginning to code that, making sure everything's working properly. You know, we've got most of the basics done, but there's a few things like inventory management. We need like tools and stuff, 3D models, all that type of stuff. So yeah. And cranberry juice. Oh, how's it going? For the series, am I going to use C++? So that's the thing. The series is going to be like a new kind of series. I'm not going to do it like traditional tutorial styles, where you basically do like follow along code and you just code everything I say. Instead, what I'm going to do is I'm going to be doing like concepts, and then I'll sort of show my code in a separate series for those of you who are interested to see how that actual code works. But I really don't want to put any code in the main series. And the reason I'm doing that is because I think we get like too focused on following other people's code, or at least I do. And I've never really learned well by following along and just coding what other people code. So I'm trying to make this so that it's more of like I tell you how to do it, and then I say, okay, now here's exactly what you need to do. And I give you specific challenges. And by the end of the series, you should have coded it if you've been able to complete all the challenges. So yeah, that's the plan. We'll see. We've got our inventory hotkeys working. Cool. So we can switch them. That's good. Let's add different blocks into them. Of course, these different blocks aren't going to have any special meaning. Well, first of all, too, let's be good programmers and add a commit, because we just did some small amount of code. So I'll say git add dot add inventory hotbar with hotkeys bound to the slots. Okay. Oh, I forgot. Okay, I was like, it gave me a really weird message. I was like, what's going on? I forgot to put -m. Okay, there we go. And then we'll push that. I had no idea what it was saying there. I was like, what is that? Okay, so that's good. Okay, what am I gonna do now? First of all, I think Flare YouTube, you mentioned we're not using grass, we're using concrete. Let's change that. And the reason I've stayed away from grass too is because the Minecraft texture is gray, and we're gonna have to add special support in our shaders to fix that, which should be pretty easy. And it'll give me a chance to go over some of those OpenGL techniques that I sort of implemented in my off time, because I finished making that work better. I'll talk about that too in a minute. Okay, for now though, if we go into our assets, custom block formats, we can go into here. So we've got, okay, so we've got grass block. It's got grass block side, grass block top, and dirt for the bottom. Okay, so that's good. We can start using that. That's ID2. So let's go into our chunk generation. Let's go down to where we generate, not render data, but yeah, this one. Just generating the block data. Okay, and we've got all this stuff. Yup, okay, so that's all good. Except what we want to do is not green concrete. If y equals max height, we want to do grass. Let's fix that. Okay, so that's ID2. So if we go ahead and run this now and we create a new world, it'll have grass, but you'll see what's wrong with this too. Gabe, will I be adding shaders on the game, like shadows, better illumination, other things? I hope yes. We do have shaders. We're using shaders right now. Grass world. But in terms of those shaders, so I love how Minecraft sort of like broken this terminology. Okay, yeah, so this is the reason I didn't have grass before. You'll see that it's quite weird. And our textures are sideways on some things. I gotta fix that. Yeah, we got these flipped upside down and stuff. I had noticed this before too, and I was like, what's going on with this? But yeah. Minecraft's completely ruined some terminology and like computing and stuff. So we are using shaders, but it's not the shaders that you expect from Minecraft. What Minecraft does when they're talking about shaders are ray tracing. And although that is cool, and voxel worlds like this are specifically designed to work with ray tracing really good, I don't know how to do it yet. So if I learn at some point, I'll add an extension to the series saying, hey, if you want to like change your game to use ray tracing, this is how you would do it. But the basic of what I'm going to be doing is going to be no special ray tracing shaders. We'll talk about that though in the future and stuff. And especially for my game, who knows? Because I plan on, after I finish coding the core of Minecraft, branching off and creating my own game that uses the space. But we'll think about that. Okay, so first of all, I think we should fix these texture coordinates because that's not right. So it looks like we have the wrong coordinates on these faces. I think it's right on this face though. Yeah, so it's right on that face, but then it's flipped over here. Let's see what direction we're facing. So you can see I've got rotation listed up there. So this is Y rotation 270. So that's south. So this is the back, I believe. Maybe. Who knows? I think that's the back. Let's see if that fixes it. We'll do, if we go into generate render data, where we generate all this stuff, the back face is what I think that one we were just looking at was. Okay, so if we go into load block and compress. Oh, this might actually be in the shader itself. The UVs. Is it? Wait a second. Okay, so we do compress, vert1, texture face, bottom right, top left, bottom right, top left, bottom left. Okay, yep, so 0 to 16 is position, 17 to 20 is texture ID, and 29 to 31 is the normal direction. Yeah, I think that's getting extracted. Wait, no, okay, yeah, so we got this data to UV index. Let's check the shaders out real quickly, because I'm blanking on how we're calculating those UVs. So we've got this UV index bit mask. Extract text chords. Okay, yeah, so this is what we're doing. So we're saying the texture ID is equal to, and then we do the text ID, and we do the UV index bit mask. And what is this? This is uint. That indexes directly into our texture coordinates. Okay. So, trying to think of how we can fix this. So what's happening here? Let me check the chat real quickly too. Miri4F, no, it's not using ray tracing. It just uses custom shaders with shadow maps and stuff. Oh, okay, cool. So it's not actual ray tracing, but they do have certain ones that are using ray tracing because you can get reflections and stuff, and I don't think you can do that with just shadow maps and stuff. Yeah, path tracing and other types of shaders. I think it's not pure path tracing, more like SSRT. I'm not sure what that is, but how many hours do I spend on my own projects, YouTube, Minecraft, coding, etc., on an average week? That's a good question. I have no idea. It depends on the week, and it depends on how much extra time I have. I try and leave enough time to do like normal things. So like not YouTube or work. So like Wednesdays, me and my friend go hiking, Sundays and Wednesdays. And then every now and then on Saturdays, I'll be hanging out with friends later in the day or with family. Like Fridays and Saturdays are usually like family. And then the rest of those weekdays, if I have some free time after work, I'll try and code from like 4 to 5, and then I'll do like dinner, and then like 6 to 8 normally. So not that much time, but Sundays are usually pretty good too. I usually have some time after we finish hiking, and then I'll code like in that afternoon time. But yeah, and I have church in the morning too, so that takes up some time as well. Okay, but this outvec2 text words. So we basically do a texel fetch, which is where we're getting the specific texture coordinate, and we use the index +0 and index +1 to get that. So if we change this, we should be able to fix how this is working, which is what I want to do. And you're just curious how you got that much done in addition to work. Yeah. So it definitely depends on the day and everything. Certain days I can code for a lot longer just because I've got more time or whatever. Especially Saturdays is when I try and get the most done. So, yeah. But it is tough, especially once you start working a lot more and stuff. And depending on how busy I am at work, sometimes I'll be staying later or whatnot, and then I have less time to do like personal coding and everything. But yeah. Okay, so we're using this index to fetch the texture coordinates. And if we take a look at our texture format file, which I think is where this is coming from. Yeah, so these are coming from here. And so basically what we have is we just have these UVs. We have 0, 1, 2, 3, all that stuff, right? And these are all the UVs for this texture. So what we really need to do is just figure out a way to make sure that we get the appropriate UV paired with the appropriate side of the texture. Okay, so if we take a look in here again. So we do index plus 0, index plus 1, which index in this case is referring to, so this would be like the start index, and this would be index plus 0 plus 1, so that's the XY. Okay, and that index is getting passed in, we can see here, through this data2 variable, which is getting ANDed together with this bit mask and everything. Okay, so I think we got this. So basically we have this data2 equals UV index shifted left 0, and we're getting this UV index from here, which is UV index. Okay, so we have these UV indices, bottom right, top left, bottom right, top left, bottom left. So are these just backwards? Yeah, I'm guessing these are probably just backwards or something. But no, we're getting it correct for one side, aren't we? Let's check this again. This is Grass World. So if we take a look in here again, so this is upside down. That's sideways. Yeah, this one's the correct way. Okay, so it looks like the UV indices just change depending on the face that we're doing. So then what we can do is we can just have a switch statement here. So we'll say switch. Let's do a UV0 thing. Okay, so this is UV index. So we can say UV index UV0 equals UV index bottom right. And then we'll just duplicate that a bunch of times. So we've got 6. 1, 2, 3, 4, 5. Top right, top left, bottom right, top left, bottom left. Oh, I actually think we only need 3, actually. 2. We could just do that. Wait, do we though? I don't know, because the order here is probably going to change up, so I'm going to leave it this way. So then we'll do UV0 here. And then we'll do 1, 2, 3, 4, 5. See, this is why it might be difficult to add different types of blocks. I'm still working on like a way to make this simpler so that we can add new block types really easily, because I don't like the way this works, but we'll have to see about that later. Okay, so anyways, we do switch on the face. We'll say case, cube, face. So this is already working for one of them. I think it's working for like the top and the front. So we'll do back first. We'll see which one this changes. And then we'll say UV0 equals UV index. We'll just kind of rotate them all. So bottom right will become top, top right. So we'll say top right. UV1 will become, if we rotate that to the left, top left. UV2 will become bottom left. UV3 will become... Can we do subtraction too? We might be able to just subtract and then modulus and just sort of rotate all these. So this is 3, 0, 1, 3, 1, 2. So if we subtract 1, what does this become? 3, 2, 1. So this would become 2. And 2 is bottom left. So bottom right, that's rotated left, is bottom left. 2 to 1 would become top left. Okay, cool. So we can just do subtraction. So we'll just do like this all minus minus. Well, we can, because we have to typecast this stuff. So we'll just say like int, whatever they are. Can we just do this implicitly though? Equals, I don't think we can. Yeah, because this is gonna complain. So we'll do int, and then we'll cast it back to a UV index. Okay. And I think you can do typecasting like either way. Oh no, I'm gonna change this because I don't like this. So we'll do that, and we'll do that. And we have to just wrap these up in parentheses. Okay, so I shouldn't have removed those. Okay, cool. So anyways, we'll just do it this way. So basically we'll subtract 1 from each of these. 1, 2, and then we'll just do duplicate, duplicate, duplicate. 3, 4, 5. Okay, and then this will be 3, 4, 5. So let's see what this does. This should modify the back face. And we might have to do this a couple times just to figure out how much we need to subtract. But basically, this should flip all of them so that they're in the correct orientation. Okay, and then we get a breakpoint. What's this saying? I failed on UV index, and that's because I have assertions, don't I? Yeah, so right now I'm asserting that all the UV indices are this way, but clearly we can't do that. We have to change them, so I'm gonna remove those assertions. Okay, so if we go back, we should be fine now. Okay, so grass world, load that. We generate all the data. Okay, cool. So now backface should hopefully, yeah, I think we did fix that, maybe. Let's see what this, okay. If this worked right, we should have 2 faces that are correct. It doesn't look like it. Are these the same though? Nope, nope. Oh wait, these 2 are the same. Okay, let's try -2. Let's see if that works. Because I'm not sure what the orientations are and everything. So if we go back, I just lost it. Okay, if we go back into here, let's try -2. We should be able to just subtract like a certain offset from this, which is kind of cool. I did not intend for that to happen when I was setting all this stuff up. Oh, and we also have to make sure we're modulus too. That's important. So we'll do modulus int UV index size. And then let's actually do plus because we don't want to have to deal with negatives here. Okay, so, and then if we go to UV index, we can just go here and then just say size equals 4. Actually, we don't even need to do that. It'll just implicitly become 4. Yeah, cool. Okay, so if we go back here, change this to size, then that should be good. Let's try this again and see if this works. So basically, it should wrap around to like the 0th indice if we need to. And I think that should do what we want it to do. Okay, so we've got 2 correct sides. Look at that. Okay, cool. So now we just need to do the same thing with these 2 sides. So that's the right and that's the left, possibly. I could have that wrong. So we just need to do this twice. More. Right and left. I'm going to make a guess. We'll do 1 for this and 3 for the other one, and let's see if that works. And we should flip all of these indices, and we should get the correct orientation. See if that works. And then we can color the grass the right color. Look at that. Okay, cool. So, no, never mind. That one's the right way. This one's the wrong way. How did one of them work, but the other one didn't? Oh, wait, I probably just have to... Yeah, so maybe it's this one. Let's try +4. I don't know. This might break one of them. So one of them was upside down, one of them was right side up. Let's see which one this changes, and then we'll go from there. Usually coding, you don't want to just be making random guesses like me, but, you know. Okay, so that did the one that was working correctly. So what we can do is we can wait for this to end. So this is kind of stuck. Okay, so change that back to 3. So this one's okay. This one is not okay. Maybe if we also do this one to 3? Because that should be 180-degree rotation, yeah. Okay, let's see if that works. So right side up, right side up, right side up, right side up. Okay, cool. We got it. Awesome. And let's just make sure the bottom texture is okay too. And we'll have to come up with a way to do this a little bit more. Okay, cool. So that's all right too. A little bit more like systematically so that we can actually get rotations, because we will have to worry about this later, where basically we generate the appropriate indices and we actually rotate vertices and everything. But that's a future problem. For now though, this looks good. Let's add a color to the top of our grass. So this is a good point now. As you guys know, I upgraded to like OpenGL 4.6. And OpenGL 4.6 requires that we use a different rendering paradigm. And we talked about that in the last stream where I was implementing it. We basically send a list of draw commands instead of drawing every time we hit a draw call. And that just allows the GPU to do more work so that we're not waiting on the GPU. So it's just good all around, right? But it means that we have to change up the way we do certain things. So this is the rendering loop now. And you can see that we just add to our command buffer this draw command, which basically just figures out what our base instance is. And I feel like that's wrong, but the fact that this is working right tells me that it's not wrong. Oh, I think it just doesn't matter because, yeah. So the base instance is actually, yeah, okay. So this tells us which draw call this would be and a list of draw calls. And this is important because of the way we have to do uniform variables now. So let's talk about this a little bit real quickly. So if we go back to here, this is my drawing from the last stream where basically, and this is just some scratch work, but basically what we have is we have this VBO that's on the GPU, and we are writing directly into this using the CPU. And we do that because we basically have a list of all the pointers where this is on the GPU. This way we can duplicate memory, duplication, all that stuff. In actuality, it probably doesn't occur like this, but this isn't what I want to talk about anyways. So what's happening is we have a list of draw commands. So we have like draw command 0, draw command 1, 2, ... up until we get our draw commands. And so these are all of our commands. And we send this to the GPU. Each of these commands contains a few different things. So each of these commands looks like this. We have the base instance, which I'll call BI. We have the instance count, which I'll call IC. We have the count, which I'll just call C, and then first, which is F. So what this basically maps to is count is the number of vertices. So we'll just say that's the number of verts. First is where this is in the GPU buffer. So this is where it's located in our big VBO. So this is our VBO position. Instance count is how many of these we want to draw. So I set this to 1 because we're basically just drawing one instance per thing. But if you wanted to draw multiple subchunks that are all the same exact vertices, you could set this to 2, and that would draw 2 instances and so on and so forth. Base instance is which draw command this is. So this is like the draw command index. So draw index. So remember, we have this buffer on the GPU. This is our buffer, which just contains a bunch of vertices. So this has like V0, V1, V2, V3, ... right? And actually, if we expand this a little bit more, what ends up happening is we then have a bunch of different positions. And so this would be like our chunk 0. This would be chunk 1, chunk 2, ... We have more chunks. So what ends up happening is this first points to the chunk. This count points to how many vertices we have. So basically, I guess I should draw this a little bit differently too. It counts to how many vertices we have in that chunk that we want to draw. So say we ended here for the number of vertices. This will draw all of these vertices. This instance count tells how many we want to draw, so we can duplicate this and draw as many as we want. And then this draw index is the index in here. So which command is this? Okay. This may all seem very complicated, but it's actually pretty good for the GPU because of the way we can send things. The reason I'm mentioning all this is because we have to change the way we do uniform variables. usually when you're doing uniform variables on the GPU, you can do like you have this uniform buffer. And this uniform buffer just is filled with whatever things you have. Like, so if you want to send, I don't know, like the position, well, okay, not uniforms. This is like our vertex attributes, right? So we'll call this attributes. So usually we send things like position, color, I don't know what else you would send, other things, right? But we send these per vertex, right? So we have like position color, and this would actually be position for vertex 0, color for vertex 0, position for vertex 1, color for vertex 1, so on and so forth. And that's sort of what we're doing here. But there's a problem, because what if we want to have like one position for this chunk, one position for this chunk? We don't actually want to embed that within every single vertex, because then we're duplicating a lot of data. So what we can do is we can say we have more attributes. This is chunk position 0, chunk position 1, so on and so forth. And then what we can do is we can say, oh, use the base instance for this guy. And so then what that does is it says, oh, okay, so the base instance is basically this draw call. So then 0 would go to 0, 1 would go to 1, 2, and then they are matching up with all these vertices. So that's a very poor explanation for attribute divisors, which are what we're going to use to specify this next thing that we have to add in, which to color the grass, we need to add, let's actually not do. To color the grass, we need one more attribute, which is biome, right? We'll have like a biome. So this is our biome for chunk 0, our biome for chunk 1, so on and so forth. And we're going to have this other attribute, and then we're going to index into it using this draw index. And then we can tell what color the grass needs to be depending on which biome we are currently in. So let's go ahead and set all that up so that we can see how it works in actuality in the code. And this is why I'm going to have a tutorial series on YouTube, because I will be explaining that way better than I did just there. Hopefully. The music is making this very intense. What's the music playing right now? Yeah, I put Super Mario Galaxy music on because I really enjoy Super Mario Galaxy, but I forgot about some of their intense music. I'm actually going to listen to this too now. And I think, Essie Woods, you used OpenGL 4.6 for the entire Mario series. Nothing wrong with that. Now you can upgrade really easily. But you can also use all the old OpenGL functionality too, which is also good. I'm actually going to take that off now because I can't hear myself. Okay. So if we go up, we can actually implement this in actuality. So we want like a biome attribute divisor. Okay, yeah. And so what you can see is I set up this instance chunk position vertex buffer, and this is exactly what I was talking about. So then I set the vertex attribute divisor for location 10, which if we look inside of our shader, actually default, I have this location 10, which is our chunk position. Used to be a uniform, now it's an attribute divisor. And if we look in here, I say that's 1, and what that basically means is for each base instance, I want you to use one of these. We could set this to 2, and then that would update it for every second draw index, 3, every 3 draw indices, and so on and so forth. We basically just need another position buffer for that though, which we could probably put inside of there, but I'm going to use a different buffer for this. And right now it's just going to contain one color because we only have one biome. But once we update to multiple biomes and stuff, this will be good to have. We can also get rid of that. So let's go to here. We have this chunk pose instance buffer, and then we're going to have a static uint32. This is going to be our biome instanced buffer. I guess we should probably call these VBOs instead of buffers, because that is what it is, instance VBO. Okay, so I'll update that later. If we go back down to here, we can sort of go ahead and create that. So we'll say set up biome buffer, and then we'll do a GL create buffers 1, address of that guy. We'll say bind the buffer, array buffer, that guy, and we'll say buffer data. How much do we want? Well, we'll say GL array buffer size of, and what are we going to use for biomes? We'll just use integers because that's the simplest thing to do. So we'll just use an integer, and then we can define, we could probably use int16, but I don't think it matters on OpenGL anyways, because it's going to upcast it to a 32-bit integer anyways. Okay, so we'll do that. Times subchunks dot size null GL dynamic draw. Okay, so this basically means we have a buffer. We have one biome thing per subchunk. So basically we can set the biomes per subchunk, which is good. This also means we can have vertical biomes, right? Because this means we can have biomes per vertical subchunk, which will be something I'll be adding in my game is, yeah, biomes up and down and biomes all around. So, yeah. Okay, anyways, so we do that, and then we just have to make sure that we actually set this up as part of our VAO. So we'll add this, which is currently bound. So we'll add an integer pointer, attribute integer pointer, and then we'll just bind this to layout location 11, which I'll add in a minute. This is just gonna be one integer, size of int32, 0. So our stride is just one integer, our offset is 0. And then we'll say this is a attribute divisor. And so this is going to be for location 11, and the divisor is 1. And then we just want to enable that. So copy that. So now if we go into our shader, we can go ahead and say layout location equals 11. And this is going to be an integer, and this is going to be our biome. So now we can use that biome to generate different things. And we'll explore this a little bit too, just to kind of illustrate how this works. So we do all that and stuff. What we need to do also is, do I have a pointer here somewhere? I thought I did. Okay, so I have this int32 star chunk pose buffer. We'll add it here. We'll say int32 star. This is our biome buffer. So we're going to add it to our draw command handler. So this is our command buffer container, which basically handles everything for me. It makes it easier. Okay, so we'll say inside of here our, what I call that biome buffer equals null pointer. And then here we will go ahead and say this biome buffer equals int32 star, allocate memory, size of int32. Why did I do this as a star? That should not be a star. Times max number of commands. That's good. I was allocating too much memory there. Okay, so we do that, and then we'll say if memory, what I call that biome buffer, G memory free, and then biome buffer equals null pointer. Okay. So now when we add one, we will also take in, so this takes in all this stuff, and then we'll add in an int, the biome, and we'll go ahead and we'll say chunk pose buffer, number of commands equals that biome. Not chunk pose buffer, but the biome buffer. So every time we add a command, we tell it what biome that subchunk is a part of. That will add it here, and everything works out magically. It adds it to the correct location for that specific draw call. Yeah, and I think, well, yeah, and then we'll have to have like a function to get that. So we'll say inline const int32 star, get biome buffer const, return biome buffer. We want to keep these buffers to a minimum though, because the more we add, the more time it takes to update all this data, which we can get around with persistent mapping, and we might do that later. But for now, you know, it is what it is. So right now I'm uploading these, you can see here. So we bind that chunk position instance buffer, and then we upload that to the GPU. We'll do the same thing, except for our biome buffer. I think I called it biome instance VBO. And then we are uploading int32, which is 1, and we are uploading the number of commands, and we are uploading get biome buffer. Okay. So that should upload all of that data for us. We're gonna have to fix one function call up here, which is the add draw command. Yeah. So for now, we'll just add biome 0, which I guess will be whatever we call it. We can fix all this too, like with an enum, and then make sure that this all works properly. But anyways, for now, we've got this biome now, so we can color our grass. And how do we know if we want to color our grass? Well, we know if we want to color our grass based on what block we got passed in. See, the thing is, though, I think like leaves and stuff are also biome dependent. Let me just check this real quick. So I'm thinking, like, do we want to add this like where we just color grass specifically, or do we want to make it so that you can color any block? That way, for different biomes, you can sort of add in different things and stuff. So, yeah. Okay, yeah, so if we look at acacia leaves, those are black and white. So we want to be able to color any block arbitrarily. So ideally what we should do is we should add this to data 2. Oh, okay, that's all fine. Let's see. So this is data 2 we have at 0x3 is our UV indices. Let's go into our, let's go down here. So we'll go to where we're generating. Yeah, okay, let's scroll down to this thingy. Yep, something down here. Okay, here we go. So we've got bits 0 through 16 are the position, 17 through 28 are the texture ID, 29 through 31 are the normal direction. Let's start doing this one too. So bits, this is 3. So bits 0 through, what is that? I have to go here now. Okay. Let's go to the drawing screen really quickly because I just have to make sure that we're doing this right. So let's go over here. So up here, I think I have all of our, yeah, vertex layouts or something. Somewhere, maybe? Okay, yeah, here we go. So basically, this is how we have the first piece of data laid out. And it looks like I've got 0, 0. So if we do 3 in binary, what is 3 in binary? That's just 1, 1. Which would be the first 2 bits. Okay, so that makes sense. So the first 2 bits are what is that? That's the UV index. So this is UV index. This is data 2. This is data 1. So this is our chunk compression technique, or our vertex compression technique. We compress it CPU side and then we decompress it GPU side. We'll allocate how many bits for biome? Or no, this is just, we just need 1 bit actually, because this is just whether to color a block or not. So we'll have 1 bit and this will be color block, color biome. Okay. So that will be UV index. So that's the 3rd bit, which is 4. No, that's 8. So we just need that to be equal to 8. Okay. Sorry about that. I had to figure all that stuff out real quickly. So if we go back to the main stream, we'll have something inside of our vertex embedded that tells us whether we want to color that vertex based on the biome. So we will go up to where we have these defined. Okay. So then we'll have a const static const int UV or color block biome bit mask, which equals 0x. We need this to be 8. I think 0x4 is 8. Nope, that's 4. Okay, so 8 is 8 in hexadecimal. That makes sense. Okay. Yeah, so we got that as 8. So now we can use this bit mask. And if we scroll all the way back down to where we had this right here, we can say, so this is bits 0 through 2. No, 0 through 1. So that's our UV index. And that makes no sense now that I'm thinking about it, because we need more bits than that for our UV index. Okay, I gotta think about this again. So that's 3. So that's just, what is our UV index? Wait a second. Let me check this again. Oh, okay. Yeah, that does make sense. So we have our texture ID, and then our UV index is just the bottom left, top right. Yeah. So if we look at the shader again, sorry. This is why it's not good to code in this way, but we're kind of forced to compress this data. There's probably a better way, and I'll have to look into that. But yeah, so we get so So this is, okay, yeah. So the UV index is indeed just 2 bits, and it just basically tells us which corner we're on. And we just need 2 bits to do 4 corners. Okay, so that makes sense. This tells us which corner to use for the texture chords. Okay, and then we'll do bits 2, 1. Bit 1. I guess 2. Bit 2 is going to be color the block based on biome. Okay, so we'll say data 2 or equals uint32. We need to pass this, which is just our biome. So we'll say int32 biome. Or no, I'm sorry. This is just a bool. Bool color block vertex based on biome. Okay, so we'll use that. And that will be shifted left. Let's see, we do 0, 17, 29. So this will be shifted left 2. Okay, yep, anded with our biome bitmask. Okay. Okay, so this is all very complicated stuff. I wish it wasn't this way. And maybe I'll change this in the future, but for now, that works. And then we'll do the same thing here. We'll say hash define. And what did I call that? I called that color block biome bitmask. We'll do the same name as uint, and then we'll do 0x. I think this was just 8. So that should get us. Wait, we want the third index. 1, 2, 4. This should be 4. Okay, so that'll give us the third bit. Let's change this up here too. So we want the third bit, not the 4th bit. Okay, so now we should be good. I believe this should all translate fine. So now if we create another function in here, we'll have a void extract color vertex biome. This will be an out. Can we do bool? Out bool? Color vertex biome. We just need data 2. So we can do that, and then we can say color vertex biome equals data 2 and with that bitmask. Okay, so we'll do all that and we'll convert it to a bool. So I think that should do what we want. Let's see, and then what we're gonna do is we'll figure all that stuff out in a minute. Okay, so we've added this bool though. Well, let me look for that compress function. Yep, those are all going to be wrong now. Okay, I don't forward declare that too, so we should be good. So let's go down here where these are all wrong now. So we'll do an integer or a bool here, bool color block based on biome. Okay. I'm trying to think if this is how I want to do this. This will give us the face. Let's do color face based on biome. That way for the grass, because we just want to color the top face for the grass. Okay. If none of this makes sense to you guys, I'm sorry for that. Hopefully it does. But just let me know if something doesn't really quite make sense, and I'll try and clarify things as I can. So let's do that. Let's do that. And we've got this. This is anded with that. And I believe, let's just double check this. Our C+ bool, a 1 for true and 0 for false. Not sure if that's true. Let's just, instead of doing that, actually, let's just do this. So we do color vertex based on biome. Let's just do that 1, 0. That way we know we're getting like a 1 or a 0. Exactly. Okay. I think this is all good now. Okay, so we do this color face based on biome thing. I think this is forward declared. So I just got to modify that. Yeah. Bool color face based on biome. And then let's see where we use that. Okay, and then we use it here. Cool. So now we can do all this on the CPU. And what's the best way to do this? So the best way to do this is going to be, we basically just get the cube face, and I guess this block format's going to have to contain which faces we color based on biome. And then when we go into here, we can basically like add in some flags here. So yeah, that's how we'll do that. But I'll be right back in just a minute, guys. So I'm going to take a very quick break, like 2-3 minutes, and then I'll be back. Okay. And if you guys have any questions or whatever, please feel free to ask them, and I'll try and answer them as best as I can. Okay. So I'll be right back, guys. All right, guys, I am back, and half a heart. I just saw that you followed a little bit ago, so thank you for that. Okay, Essie Woods, that code looks neat. I'm glad you think so. I actually think this is... I don't know which code you were talking about, so there's some that looks neat and there's some that doesn't. This music is a little bit too intense. Let's go ahead and switch it up a little bit. Let's do some Nintendo music, okay? Yeah, I think this is the one I was using before. Yeah, this is much better. Okay, we'll use this for now. All right. So we've got all this. I think what we want to do is add in some way to our block format to basically tell which faces we want to color. So like grass block, we want to, and we can add like default values too. So we can like do color top by biome, true. And then all the other faces will just automatically like default to false. That way we don't have to specify everything. But this way, if we have something like acacia or like oak leaves, we could go ahead and say like ID, whatever ID we wanted to use. I think 7 is the next available one. Nope, 8. So let's actually put this down further. So then we could put that down there, and then we could go ahead and just say like, grab all this stuff. So then we could go ahead and say like, this is like the oak leaves texture or whatever. I'm not sure if that's right or not, but we do all that. And then we could go ahead, this is probably true, but then we could go ahead and say like color side by biome, true, and then true, I don't know what that was. And then color bottom by biome true. That way we can like set individual faces if they need to be. So I think this is what we want to do. Okay, so we've got all these different flags. Let's add these to our block map, and then they'll all default to false as needed. So let's go ahead and just clear some of this stuff out. Man, this is all to color grass. I thought this was gonna be a simple thing to add. But yeah. Okay, so let's go ahead and we will go to our texture format. So we've got all this. I think this is, okay, block format is what we actually want. So bool color top by biome, color side by biome, and color bottom by biome. Okay, so we got these bools. We're gonna have to clean this stuff up too, because I really don't like the way this works, but you know, for now it works, so we will keep it. And when we're loading things in, we can go ahead and say, where do we load these? Okay, I think we load them right here. Yep, so, okay, yeah, so we get all this stuff. So we'll say bool color top by biome equals block dot second, and then we'll say color top by biome, and then we'll say dot exists or something. Yeah, so we'll say is null, which I think, or yeah, I think that, okay, is defined. I think that's what we want. So is defined. And then if it is, then we'll take whatever it says. So we'll say block.second, color top by biome. I don't know how I type in there, but yeah, okay, as bool, otherwise false. Okay, so that's sort of the strategy we'll use. And if we go back into here, we can grab that. And then we can also grab this. Okay, and then right here, we can go ahead and say top, side, and bottom. And if we look into here, top, side, bottom. Yep, that's all correct. What's this saying? Okay, yeah, so we're good there. Cool, so we'll do all that. Should load those values in, and now we've got that in the block map. So now if we go back into here, we can figure out whether we need to color this. So we can say bool color by biome equals top block dot color top by biome. I guess we can just pass that through. There's no need creating an intermediate for that. Okay, so then we can use this to figure that stuff out. So then here we'll say bottom block dot color bottom by biome, and then for the side faces we'll just use color side. So we will say right block color side. Is this right? Wait a second. Okay, yeah, this is right. Okay, I'm saying right block here. This is the right face. That's very confusing, and I should fix that in the future because I got really confused for a second there. Okay. Or wait, no, yeah, this isn't right. Okay, never mind. I'm using the wrong things here. So this is the bottom block. What we want is our block format, which is this thing. Okay. Yeah, so we want to use our block format, color by top, color by bottom, color by side. Okay, that's what we should be using. And then for the left face, we want to do the same thing. For the forward face, same thing. For the back face, same thing. Okay, so now we can check and see if this is working properly by basically going into our shader. And we'll add some bad shader code, but I don't care right now because I just want to make sure this is working right. Do we pass a color out? We have these things out. We'll pass out a vec3 f color. And then inside of here, we'll take in vec3 f color. And we'll multiply by that f color here. So we will say multiply by f color 1. Okay, so that way we get that color shift in there. Yep, I like that. And what's this saying? Okay, cool. So we're all good there. So what we'll do now is we'll say like f color equals that, and then I'm gonna put an if statement in here. We can change this in the future, but basically we'll say if we actually want to extract something too. So which is color vertex by biome. Yeah, okay, so we want to extract that bool. So we'll say bool color vertex, and then we'll say extract that. We'll pass it data to that, and then we'll say if color vertex biome. Then what we'll do is we'll say f color equals 0.8 that. Okay, so we'll do this just to test to see if this is working. So what we should see is like the grass should get the top colored weird, and then the rest of the side should be normal. That was a lot of code that I wrote, so hopefully it works. Okay, so let's go ahead and let's load our grass world. And it's not working. What do we get? So, undefined variable data 2. That shouldn't be undefined. Color vertex biome. Did I do typos in here? That should be a data 2. That should be by biome. Okay, there we go. So let's just rerun that. Another breakpoint. Yeah, broke something else. Okay, implicit cast from vec4 to vec3. Too much data in type constructor. What am I doing now? Okay, so that's a vec3. Vec3. Oh, that should be vec4. Okay, there we go. So now we should be good. And is this gonna work now? So, is this getting a hue shift? I can't tell. So if this all worked properly, what we should see is the top block should, or the top face should look different. But I can't tell. Oh, I multiplied by a grayscale value, so of course it's not gonna do anything. Let's multiply by like an actual color. We'll do green, because that is what we want, right? Okay, so let's multiply by green and see if this works now. I think it might have though, because it looked different. Oh, look at that. Okay. It's working, guys. We did it. All that code actually worked first try. That is a rare occurrence. Now we can multiply certain faces by different colors. And you can see how this works too. So if we were to go in and change our vertex format now, what should happen is we can turn on different sides to be colored. So if we say color side by biome to true, what we should see is that now the side will be greenish too. And we can sort of turn these on and off just by changing the format of the block. Okay, yeah, so now you can see that the side is like shifted to a green hue, and then we could do the same thing for the bottom if we wanted to. Okay, I am really happy with that because it's actually working right. Let's find a better color for that green though. Let's also get rid of that. So, HTML color picker. This is what I use whenever I need colors. Let's go with like this color, right? Oh, it's good. So that's those values. And then we'll go into our shader code and we'll change this up to that over 255. And same thing there. And now we have colored grass. Just like that, right? Very easy, kind of. That actually looks kind of like Minecraft. We're finally getting there. It's kind of bluish though. I don't really like that. Let's adjust that a little bit. Let's see. Let's shift more towards a green. Okay, so let's do that. See if that looks better. now would be a great time for me to add in like actual in-game editor things that I can use to adjust these values, which I could technically do pretty easy, but I have to expand my IAM GUI library stuff to sort of work with that. Okay, let's see if that looks better. Yes, Langors, I agree. We finally have it. I don't know what that emoji is, but we finally have it. Okay, yeah, that looks like Minecraft now. Okay, we're finally getting somewhere. Now let's add different blocks to our inventory slots to see if this works. And you'll notice it kind of lags, adding new blocks and stuff, but that's because you'll also notice we were still generating chunk data. So it's like the threads were kind of working, but now that we're done, they're instantly added. So it's like, if we're working on certain chunks and stuff on the background threads, then we might get delayed adding new blocks and stuff because of the way the priorities work and everything. So I'm gonna have to add some stuff to fix that. But yeah, let's add different blocks to our inventory so that we can actually switch around to different blocks. So I'm gonna hard code these values in for now. If we look in the player controller, you can see that somewhere in here. Okay, yeah. So we've basically got this new block thing, which is how I'm checking, and then I just place a sand block. And I'm doing that for breaking blocks too. That makes no sense. Let's remove that there. Okay, yeah. So let's go ahead and we'll add an array up here. Static int hotbar block IDs. And this will be an array of 9 things. And we'll add in the blocks that we want to be able to use. So let's see inside of here. Not there, here. Okay, so we can add in, I want to be able to use grass blocks, sand, and dirt, I guess. So that's 2, 3, 4, 6. We'll do those for now. So 2, 3, 4, 6. We should be able to use that stuff. And then we're gonna need a few more. For now, we'll fill those out with zeros. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. And then here, what we can do is when we place a block, we will just use hotbar block IDs, and then we'll use the index of main HUD current inventory slot. Okay, so that way we basically select the block ID based on what's in there. So now we should be able to place down different blocks. Slow and steady wins the race. This is really shaping up. I agree. And I hope I'll be able to offer something different than a lot of other Minecraft clones have done. I haven't seen a lot of them that like actually allow you to build an inventory and everything, right? Most of the Minecraft clones are just like the world generation, and they don't really go into like inventory, menus, and all that stuff, which is really important for a game to actually work right. Okay, so that's a grass block. That's still a grass block. That's still a grass block. Okay, so I clearly messed something up there. What did I mess up? Oh, this is static. We should make this not static. Actually, we can make that static, and then what we'll do is we'll just say new block .id equals that current inventory slot. And then we can just set that to 0. Okay, so now we should be good. This is on a whole other level. Great, I'm glad you think that. So that is what I was hoping for, because there's so many Minecraft clones now, it's like you have to have something different if you want people to play it. Okay, so that's grass. That's sand. That's dirt. That's stone. Okay, cool. Let's add some other blocks that we can use now. So I'll close that out. So we got oak leaves. Let's change that to 9. And we'll add oak trunk. I don't know. I think that makes sense, right? I can't remember what Minecraft calls it, but... and this will be ID 8. Side will be oak. Let's see what they call it real quickly. I'm actually going to do this. That's not right. Okay, oak. Okay, so we've got oak leaves. So that's all right. Oak log, that makes sense. .png, and then oak log top. So this will be oak log. and then this will be oak log. Top is oak log top, bottom. Okay, we got that. Is solid, is true, is transparent, is false. I should add default values for these two. I'll do that eventually. And then we don't want to color that by biome. So now if we go ahead, we can add those block IDs. That's 8 and 9. So let's go ahead and we'll add 8, 9. Let's see if that works now. We've made quite a bit of progress today. I still have to fix this, but I'm pretty happy with the progress we've made so far. Okay, so we have those. I think 5 is the next one. That's an oak log. 6 is an oak leaf. Look at that. And we don't have transparency yet. So we will have to fix that, but now we can actually make like an actual kind of house, right? Let's do a little bit of a... Okay, I'll go over here. 1, 2, 3, right there. It's really cool when like this is finally working out to where we can actually build stuff now, right? Okay, so let's do that. Let's also clear some of this stuff out. I need to adjust the player controller and stuff too, because it still doesn't feel quite right. And let's add oak planks into here so that we can do some more types of blocks. So we'll save that real quickly. And we'll do 10, which is going to be oak planks. So we'll do this. Actually, we'll copy this one. And then we'll do... do I still have search everything? I don't. Let's open that up again. Oak planks. Yeah, okay. That's just called oak planks. Cool. Okay, so now we should be able to build ourselves a little house. This is finally getting places, right? Okay, so let's open that one up again. And if we go to, I think that was 7. That's oak planks. Look at that. Okay, let's do some scaffolding here. It's not cool that you have to remember what to use, but we can fix that pretty easily in the future. For now, I'm okay with this. Oh no, I killed myself. Okay, so there's still some physics bugs that we have to fix and everything, right? I placed a block and then I was inside there and then it kind of glitched me. So we got to fix that and stuff, but you know, progress. Essie Woods. Oh wait, okay. Tribread, what playlist am I using? We are using Nintendo music to play on stream. My brother showed me this and I really like it. So just look up Nintendo music for stream and I think you should hit it. Let's keep building though. And Essie Woods, Langors, I forgot about your reply about the game I mentioned. Yeah, it looked awesome. Okay. So, okay, delete that. I want to keep adding to this little house and see if we can get a whole house up. 7. And then we've got a little window. I am really happy with the progress, guys. We are finally going places with this thing. Okay. And then we'll switch that floor to be stone. I think that's stone. No, that one's stone. Yeah, okay. Oh, I have to fix that debounce for placing blocks. I was not able to place blocks there. Look at that though. We've got like a little hut kind of thing. We'll add leaves to the top since I can't really add other blocks. Oh yeah, we can add bushes. So we got some bushes there too. Let's go ahead and add that as the roof too. Oh crap. You know, it's almost like the real game. Not really, but slowly but surely getting there. One of the other things I want to do too, I don't know if you guys have seen that mod, like the better leaves or whatever, better foliage, where it basically adds like extra stuff to the sides. But I want to add that as well because I think that looks pretty cool. If you've seen it, you'll probably know what I'm talking about. Okay, so let's go ahead and add this around. Would you look at that, guys? This is a house we've built, and we can exit and we can save. If we can exit that, we can load that world back up. You know, this is turning pretty good. Yep, so we can load this back up and it works. So I guess one of the things that would be good to add would be like transparency, so that we can actually add transparency and stuff to these blocks. But that is going to be a pretty big thing, because in order to add transparency, we've got to add like sorting, which I kind of already have. So one of the things I also didn't mention, if we go into the chunk manager, I'm actually culling chunks and sorting them. So if we go up here, and which has improved rendering times really great too. And Langors, exactly, wait, let's see. Oh, about the transparency. Okay. I was like, what? But yeah, I actually am sorting stuff already. So we can add stuff to our sorter to basically do that pretty easily. But I have to add in a method to add transparent blocks to a specific subchunk. And that one will have to like be only transparent blocks so that we get that draw in the correct order. But yeah, basically, if we look at this, you can see that I've got, well, first of all, yeah, I've got this thing. We say if the box is visible within the frustum, and this is checking whether our chunk is visible within the frustum. So an interesting thing we can do is if we actually change this to this, you'll see how it's culling certain chunks that are out of view. So if we increase that, you'll notice that we can actually see like the edges of the screen disappear, because I am culling stuff to speed up rendering time. So if we do that, I probably didn't do that quite enough. Okay, yeah, let's do that again. I gotta wait for this to finish though. Let's do that up to 48. Okay, so if we do that, I think that should be what we're looking for. Nope, it looks like I still didn't get that quite right. But basically what's happening is I am culling the different subchunks. So like you can see up in the top left corner, it says draw calls right here. And yeah, so if you notice, like when I look away, the draw calls go down because nothing's in range, and that's not working quite right because I changed this. So I'll change that back. But yeah, so if something isn't in range, we just don't draw it, which makes it speed up. And then I also do sorting afterwards. So we got this thing which sorts our commands, our draw commands, instead of sorting like the actual vertex data, which is also really nice. And if we look at the sort, I think I have a compare function. Yeah, so we sort it based on this. So basically by the distance to the player. That way we reduce overdraw. So we draw the chunks closest to the player first, which means that we improve our rendering times. If we were to switch this, that would decrease rendering times really. Let's actually do it. We'll do this. And it should slow things down because now we're doing a bunch of overdraw. In Langors, I think that leaves, you can just discard the fragment if you don't want to have sort, if you want to see the effect. Oh, that's true. We'll do that in a minute, just so that we can see the effect. And Essie Woods, that hut reminds me of a YouTube video where we create an insane underground castle with bridges, etc. Almost the same. Cool. I think we're missing a little bit though. And Langors, and then do it use, yeah, sorting the correct way. Yeah, we'll do that in a minute. With that changed, we should get slower rendering times. It's not going to be noticeable, but the GPU is now working a lot harder since I changed that flag, which I don't want to keep, so I'm going to change it back. But yeah, I did some performance profiling and stuff just to make sure everything was working properly, just to get that all right. We'll go and do what Langor suggested. So let's go into default shader. We'll say if frag color.a equals 0, discard. I actually don't think I can use discard though in this version of OpenGL. I think they deprecated it. Let's see. We will find out. No? Okay, didn't deprecate it. Okay, yeah, it looks like I've got to add in that vector to our color or whatever. Let's see. So if we look at where we sampled the texture from, yes, we get our texture. Okay, yeah, I should be doing vec4 here. And that should be good. And then we can just say if object color. Okay, so that should do what we want it to do. It might do some weird stuff. Wait, okay, yeah, so... Oh, wait, no, that's a different error. It might do some weird stuff since it's going to actually discard this fragment. So we'll see what happens, but... let's see, we'll do that. For now, we'll just do that, and then we can sort of fix all that stuff later. Okay, let's load that. Yeah, so it's gonna do some weird stuff because, actually no, yeah, so this is looking good. And if I just say that this is transparent, I think it'll generate the faces around it. So let's go fix that in the block format, which is here. Yeah, so let's change this to true, and I think we should be good. And we've got leaves that actually work, maybe. Yeah, look at that. Hey. Okay, cool. Good idea, Lingors. It's good to just see it working. This is another interesting thing that we'll have to fix. You'll notice it kind of just goes all the way through the block. We should be drawing the back faces of this as well. But it looks like we're not because we have back face culling turned on. So we'll have to fix that for transparent blocks where it basically renders the back face as well, just so that we get both sides. But yeah, that looks pretty cool. And then if we go into here, we can see that. Cool. I'm really happy with the way this is turning out, guys. This is like turning into a legit game. The one thing I want to fix too, maybe we'll do this today, I'm still debating, is getting the menu screen like looking a little bit better. Let's go ahead and just remove this stuff too though, because we can. Okay, and then I'm gonna fill this back in. Sorry, I'm enjoying playing this game that is actually starting to work. This is pretty cool. One other thing that we need to add. So I guess this is a good time to ask you guys, what do you think we should add? And what order do you guys want me to go about adding it? I know we need to add in lighting, proper lighting, so we can add like real shadow. Well, not real shadows, but you know, Minecraft shadows and stuff, torches and all that type of stuff. We need different block types, which is important. We need proper inventory management. So like where I break a block and it pops out a little entity. So I'm going to ask you guys, what do you want me to implement next? And I will begin preparing to implement whatever you think would be the coolest. Langors, yep, by the way, it would be cool to change the color of some grass and leaves and add seasons. Yes, that is one thing me and my brother were thinking. Cranberry juice, think water is a big one. Yeah, water is a tough one too, because that's like a whole nother range of stuff. But if we're gonna do water next, then that would be like transparency. So getting transparency working right is what that would be. Tribread says lighting and day-night cycle. I like that idea too. And actually, we can do a day-night cycle pretty easily too. So let me do that. Let's do that real quick. I don't have fog, do you? I do have it. I just sort of scaled it down for now. But we can fix that up pretty easily too. So if we go into the world.cpp, we actually have this thing in here, which is the sun position. Let's see, where is it? Yeah, okay, we've got this. Yeah, sun position. And then I'm just hard coding this right now. What we could change this to is U sun direction. Let's go into the shader. And then we'll change this to U sun direction. And down here, we're actually using that right now. So we can do this. Instead of doing that, we can just say light direction equals normalize the sun direction. And then we can go into here. And I'm trying to think of how we should format this. We basically want to have it like pointing down, and then we can like rotate it is what I'm thinking. So we need a circle. So we'll just say like a static float sun X rotation will be 0. And then as this rotates around the X axis, we should like have the sun rotate. So we'll do this real quickly because that's actually pretty. And Langors, that is something that's easy to add and fast. Yeah, so we'll check that out too in a minute. Okay, so if we have the X rotation, let me go to the drawing screen real quick just to explain what I'm gonna do. Okay, let's scroll all the way back down. So basically what I'm thinking is we have, that's horrible. I can't do that to you guys. Let me get some lines. Okay, so basically if we do a couple lines here. Okay, so let's imagine that this is like the world height, right? So we're like looking at a side of the world, right? So if we were doing blocks, like my house would be going up like that and like that, whatever, right? So this is the Y direction. This is our Z direction, and this is our X rotation going around this way. So how do we get which direction the sun should be? Well, the sun should be facing in like this, and then we can like rotate it all the way in a half circle. And then when we get to here, technically it would be night, and then we would have the night cycle. So this would be night, day. And what we can do is we can basically just get the direction of this vector pretty easily. This is our theta, which is our sun's rotation. And how do we get this vector? Well, this is just cosine theta. This is sine of theta. Okay, so that's what we need. Let's go back into the code. So we got our sun's rotation here. We'll say glm vec3 direction vector, and this is just going to be equal to we'll do, okay, so that's cosine theta, sine theta. For that's, I'm trying to think of how we want to do this. We'll do that as the xz. No, we want to do that as like the x, or the zy, I guess. Okay, so we'll do like vec3 0 for the x, and then we'll do y is sine of theta. So we'll do that. And z is cosine theta. So we'll do, okay, we do that. And then we can do u sun direction is direction vector. We'll upload that, and we should be good. And then what we can do is we can say static int sun ticks equals 0, sun ticks plus plus. And then we'll say if sun ticks is greater than 10, sun x rotation plus plus. So we'll increase our rotation every 10 ticks, which is 10 frames, which is like 6 times a second. So we should see it start to rotate. Let's see what happens now. I'm interested to see if this works at all. Voxel Riffs just came back from a long and hard struggle of adding variadic arguments. Awesome. Your language is turning out pretty cool too, by the way. I really like the way it's turning out, and hopefully we'll be... Oh, cool. Look at that. We'll be able to get to see that soon. Day-night cycle, guys. We've got it. It's kind of going weird, though, so I think I might have messed something up. And it's going way too fast. Yo, great timing, huh? Yeah, you did have good timing there, right? So if we wanted to slow this down now, too, we could very easily just go change this to, like, 50, and that, or actually let's do 60. So basically every second it increases, and then we can say, let's add one more variable up here too so we can change the time of day. So we got a uniform here, and then we'll have a uniform bool u is day. And then here, we can change the light color depending on what time of day it is. So we have the light color here, which is 111, which that's also very bright. We should change that to like 0.8, just to tone it down a little bit. Okay. And then what we can do is, like, for the nighttime, we'll just give it a bluish hint. So that's RGB. So we'll just change the blue slightly. So the blue will be, if we want to do this branchless, is day times 0.8. Let's see. Is day plus 0.8 or something like that? I don't know. We'll see. For now, though, we can just do an if statement because I don't want to do branchless programming right now. Okay, so light color dot b equals is day 0.8. Otherwise, we'll do like a 0.4. Or actually, we want to increase the blue, so we'll do 0.9. And then if we go back into here, upload bool. I don't have that yet, so we'll add that in a minute. Yeah, we'll add that in a minute. So we'll say u is day, and then we'll just do that based on sun x rotation is greater than 180 and sun x rotation is less than 360. Okay, so we can do that, and then we can also change our light direction. And what we want to do is, yeah, if it's day, we'll say light dir equals is day. Otherwise, we'll flip it just so that we have it pointing in the right direction. Okay. So let's add that upload bool to our shader, which we can do here. Void upload bool const char star var name bool value. And then add that to our shader implementation. Scroll all the way down here. And we can do this, that, and we can say GL uniform 1B. Do they have bool? Let's see what the GL docs say. GL uniform 1F, 2F, 1I, 2I, all that stuff. Okay, let's see. So modifies the value of a uniform by location. The number specified should match the number of components. Okay. So 1 for float, int, unsigned int, or bool. Okay. And then the suffix f indicates floating point values. The function should be used to provide values for uniform variables. The UI invariants are for unsigned. The f is for float. Either the I, UI, or f variants can be used to provide values for bool. Okay. The uniform will be set to false if it's 0. Okay, cool. So we can just go ahead and say like GL uniform 1IV. And then that will be 1. Wait, no, not 1IV. GL uniform 1I. And if we look at this, it takes in a value, and then we can say value. There we go. Okay, cool. So that should get us that uploaded. If we go back into world.cpp, I think we're all good now. So now it should turn blue at night, and then we should get the proper rotation and all that stuff. Oh, and I should also modulus that 360. Wait, one more thing. Okay, sun x rotation equals sun x rotation mod 360. That way we wrap around. Is this a float? It is. We'll change this to an int. And then we will change this here to a float. Okay, so now do we have a true day-night cycle? Let's see. Oh, Eddie Dev upload assign integer. Yeah, I just saw that. A little bit too late, but it's okay for me. I think you posted that at a good time. Okay, I think I've got a problem. Yep, is day. Let's change that to you is day. Okay. And now we should get day-night cycle. Oh, yep. You could see it changed pretty... Oh, okay, so what's happening there is because I'm flipping it for the day-night cycle, what we should actually do is, let's flip it on the CPU side first of all, so I'm going to get rid of this in the shader. And then here, what we can do is we'll flip the Y value. I think the Y value is the only one we need to flip. So we'll say, what is that? Direction vector dot Y equals sun X rotation. This. Then we'll do direction negative. Otherwise, the same one that we have. Okay, so that should just flip the Y so that it still looks like it's going in the appropriate direction. It might look like it's going like this, though. Like back and forth, which probably won't be good. If we look at it from this direction, does it look better? Okay, yeah, this looks a little bit better. Looks like we're still lighting from the underneath though, and I don't like that because we shouldn't be lighting from underneath. Essie Woods, how many languages am I familiar with? Let's take those headphones off real quick. I think I'm familiar with a few. Well, I know I'm familiar with a few, but I'm trying to think of all the ones. So C++, C#. I use C# at work right now. I use Java at one of my old jobs. I'm going to be using JavaScript and React and all that stuff for my new job. So I know JavaScript and TypeScript and HTML and CSS, the web dev sort of stuff. Those are like the main ones. And then Python is like the scripting language that I typically use. I have used Lua before. I've used like Lua. I've done a very little bit with Haskell. And then C, of course. I mean, C++ and C. And I'm trying to think if there's any ones that I'm missing. Yeah, so C#, Java, C++ are the big ones. Yeah, okay, I think that's about it. So, yeah, programming languages. And new job, yes. So that's why I have this deserved vacation, I guess. So next week I'm going to be off for a little bit. I'm going to slow down this sun too because I don't really like how fast it's going. We'll change this to like 60 times. Oh, the reason it's going so fast is because I never reset this. Whoops. Sun ticks equals 0. But yeah, I got a new job that I will be starting pretty soon. And thanks, yeah. My old job was good too. Like, I definitely enjoyed it. My last day was actually yesterday, which is why I'm streaming today. But I just wanted to try something different. So, yeah. Voxers, I should give Haskell a try. It's so different from conventional C-style programming languages. Yeah, it's very weird. That's why I only very slightly used it. I want to learn like an actual pure functional programming language just to get used to it, to see if I can use any of those techniques in my regular programming styles. But I just haven't gotten around to like actually using it. Let's change that to 20 now because this should be better. But yeah, I want to learn like actual functional programming because without functional programming, Google wouldn't be a thing. That's basically the magic of how Google works. Okay, so now we've got a much slower day-night light cycle, which I like. It's still pretty fast, just so that we can actually see it happening and stuff, but I'm gonna have to change this too, because it lights things weird. And this is why we have to add proper lighting too. Like, this block shouldn't be lit the same as this grass. It should be lit differently since it's underneath. So that's something we'll have to add. which shouldn't be too hard, but I just don't want to think about it right now. But yeah, with that programming CV, getting work should not be a problem. Yeah, I mean, I feel like most jobs are wising up to the fact that like you don't need to know specific programming languages to be a good worker inside like a job and stuff. And I hope that's the direction we actually go more in the future too, because like programming languages don't really matter. It's what you know about how to programming, because the language is just a tool to get the job done. And so as long as you know how to program like data structures, all that stuff, data structures, algorithms, everything, then you should be able to pick up any language you need to and get the job done. So there are different quirks and stuff that you need to know, but yeah. Voxriffs, the regular Minecraft style, one step reduces light level type of lighting. Oh yeah, that's what we're going to be going with for now. I might change it in the future, and I also want to add colored lights into my version, because, colored lights. So we'll be doing that as well. But yeah, basically one step reduces light level, and we'll just like linearly interpolate between the different light levels around you and stuff. Yep. And as you would, I agree. I think they often look how to be able to, the person is able to learn fast and efficient. Yeah. And I really hope jobs too in the future, like they place such a heavy emphasis on years of experience at a real job, which I think is just so stupid, because like I don't have many years of experience at real jobs, but I know how to program, So yeah. And Voxriffs, I also noticed it's using less than a gigabyte now. Yes, that was the big change. So basically by upgrading to OpenGL as-do techniques, we are getting pinned memory from the GPU, which allows us to use like, to reduce the memory usage, because instead of writing to the CPU and then copying to the GPU, we can just write to the GPU directly. In actuality, it's probably pinning memory between the CPU and GPU and then initiating a DMA transfer every time we write and then just uploading it super fast. But yeah, short story is we use much less RAM now. So yeah, you need to watch that VOD now. Yeah, I only implemented it halfway and then didn't get it completely done just because I was running into some problems I didn't know how to fix. But if you want to learn about it, the OpenGL Super Bible is tremendously helpful in that regard. And hopefully when I actually release the series, I'll be able to explain that stuff a little bit better. Guys, I am really happy with the way this is looking though, right? We've got the ability to place down different blocks. Whatever we want. We can build stuff. We can break stuff. We've got lighting, sort of. Day-night light cycle, kind of. Fog is gone for now, but it'll come back eventually. I think what I'm gonna work on in the next stream is probably proper biome generation and terrain generation. Right now, we're not really doing anything fancy. I want to actually start doing like caves and stuff, and I think that's the best next step, because we've got all of this stuff working pretty good. In the meantime, and I'll actually be streaming too, yeah. So let me close that out. If you guys are available and if you want to, this whole next week, I'm going to be trying to stream every single day. We'll see how it goes, but yeah, we're going to be doing a lot of work. I want to dedicate these 3 days to getting this to a good state. And then these last 2 days, I'm probably going to be working on my math animation library, because I need to upgrade it a little bit to work with 3D stuff so that I can actually build the animations for this next tutorial series. And then this whole month, I'm going to be starting a new job and hopefully working on that next video. And then I'll be releasing that next video probably towards this time frame, which will be the first video in the Minecraft series. So that will be very fun. But yeah, if anybody has any questions, ask them now, because I'm probably going to drop off in just a minute or two. I am really glad you were all able to make it though. Thank you for coming. And hopefully you'll be able to make it to some of the streams next week. If not, that's fine. But we'll be adding in a lot of new stuff, like inventory management for real. Commands, so that you can give yourself different blocks and stuff, is something I want to work on, like a command parser and everything too. And like entity drops and everything like that too. So yeah, and transparency for real. SE Woods, when is the crib tour? That'll be, right now my camera is like hooked up, so I can't really pick it up and take it around, but we'll do that eventually. My crib is very sparse right now, so maybe in a few months when it has a little bit more stuff. Yeah. Anyways, guys, thank you all so much for coming, and I will see you next time.